4.5, we're going to talk about implicit differentiation. So we're continuing with our derivative strategies, but doing it a little bit differently in 4.5. So an explicit equation is where y is given alone on one side, where y is in terms of x. This is what we're used to taking the derivative of. If I took the derivative of y here, our derivative would be 6x. An implicit equation is where y is mixed with the x's. So that's what we're going to be taking the derivative of now, an implicit equation. So where y is going to be mixed in with the x's. Sometimes we can get the y to be all by itself. So for example, 2 on the left side, my y is a GCF, so I can take that out. I'm left with 1 plus x equals x. And then I can divide by 1 plus x to get that y all by itself. So y is equal to x over 1 plus x. Can I take the derivative of this? Can I take the derivative of this? Yeah, what would I use to take the derivative? Quotient rule. So we can take the derivative using the quotient rule. Similar to number 3, we can get the y to be all by itself. I'd have to subtract x squared. So y squared equals 4 minus x squared. What would I do next to get the y all by itself? Awesome, square root both sides. So what would y equal? If I take the square root of both sides, what do I need? Plus or minus square root 4 minus x squared. So sometimes when you have an implicit equation, you can end up with more than one function of x. Here we've got 2 equations, y equals positive square root 4 minus x squared, and y equals negative square root 4 minus x squared. Which we could take the derivative of both of these, we'd just end up with 2 different answers. So sometimes you can have more than one equation. Let's try an example 4 to get y all by itself here. Let's put all of our y's on one side. So I have 3y cubed minus 9xy is equal to, I'm going to subtract that 2x cubed to the other side. So now I can take out my GCF of a y. And I'm left with 3y squared minus 9x equals negative 2x cubed. Divide by 3y squared minus 9x. So we get y equals negative 2x cubed over 3y squared minus 9x. Did I get the y all by itself? All the y's all by itself? No, I still have a y on both sides of my equation. Is it possible to just get a solo y on one side here? In this question, it's not possible. So in the little note on the side, it says, if or when it's not possible, we need a method called implicit differentiation. So we're going to be using implicit differentiation to find the derivative when we can't get the y all by itself. Even if we can, there's some questions on the homework that you could get the y all by itself, but we're going to still do implicit differentiation there. So we'll end up with a y in our answer. All right, so we're going to be taking the derivative using implicit differentiation. You must think of y as a function of x. Step 1 is to take the derivative. You can use d over dx on both sides, but we're just taking the derivative of both sides. What's the most important here is when you derive y, you must write dy dx after it. So anytime you take the derivative of y, you have to write dy dx after it. So that's going to affect our answer. It's going to make it just a little bit different than what we're doing before, but we're still just taking the derivative. But if you take the derivative and y is there, you need the dy dx. Just included after. And then for our final answer, we solve for dy dx. We just want to get that dy dx all by itself, and it'll be dy dx equals our answer. So let's take the derivative of example 5. So here, I'm going to take the derivative of x cubed. What would our derivative of x cubed be? 3x squared, perfect. Plus, what's the derivative of y cubed? 3y squared, but when we take the derivative of y, we need to include dy dx after. So it's the same thing as if we were taking the derivative of x, we just have to make sure we include that dy dx after it. Equals, what's the derivative of 5? 0, perfect. Now we want to get the dy dx all by itself. So let's move everything else to the other side. I can subtract 3x squared. So 3y squared dy dx equals negative 3x squared. What would we do next? So we're going to get that dy dx all by itself. Awesome. It's being multiplied to the 3y squared, so we divide by 3y squared to move it to the other side. So dy dx is equal to, we can simplify a little bit here, the 3's cancel, so that would be negative x squared over y squared. That would be our derivative. Right. The second way we could have solved this is we can get the y all by itself here. Here we can make it y equals. I can subtract the x cubed to the other side, so y cubed equals 5 minus x cubed. And then we can take the cubed root of both sides. So we have y equals the cubed root of 5 minus x cubed. Well, if we were going to take the derivative of this, we like it when we have an exponent. So we can make that cubed root what as an exponent? The 1/3 power. We can take the derivative here using our chain rule. So our derivative would be 1/3. The inside stays the same, 5 minus x cubed. Subtract 1 from the exponent. So it'd be minus or negative 2 over 3 as our exponent. Then we have to take the derivative of the inside. What's the derivative of 5 minus x cubed? So negative 3x squared. Thank you. When we do a little bit of simplifying, 3 times 1/3 would just be 1, so that goes away. So on top, we're left with negative x squared, and on the bottom, we have 5 minus x cubed to the power of 2/3. Since it was a negative exponent, I moved it to the bottom. So this is our derivative, which is actually the same thing as what we found, except when we use implicit differentiation, we have a y in our answer. If I were to replace y with what y is equal to, here I have y equals 5 minus x cubed to the 1/3 power. If I took 5 minus x cubed to the 1/3 power and put it in that y spot, I would get this as the answer. You don't have to do the second way for implicit differentiation when you have y's in it. Just leave the y in your answer. You're going to leave it as y. This is the answer. I'm just showing you it ends up being the same thing if you get y all by itself and then take the derivative of it that way. But on the web assign, it's just it wants y in your answer just like this way. On the test again, same thing. It wants y in your answer just like that. So you don't have to do the second way, just showing you how it works. Any questions there? All right, let's do the same thing with example 6. We're going to derive using implicit differentiation. So we don't need to get the y by itself. We're just going to take the derivative. But on the left side here, we're multiplying x times y. So if we're multiplying these two together, how would we take the derivative? The product rule, perfect. So we have the first, I'll write it here, first times the derivative of the second plus the second times the derivative of the first. So our first is going to be x times the derivative of the second. What's the derivative of y? 1. But what do we have to remember we include when we take the derivative of y? dy over dx plus the second, which is just y, times the derivative of the first. What's the derivative of x? 1 equals, what's the derivative of 1? 0. Perfect. So if I write this just a little bit neater, I've got x times dy dx plus y equals 0. Now we want to get the dy dx all by itself. So what should we do? Perfect. Subtract y. So x dy dx is equal to negative y. And then what? Divide both sides by x. So dy dx is equal to negative y over x. So this would be our answer. Okay, let's look at example 7. Yes. All right, example 7. Given y squared minus x plus 1 equals 0, we want to find the slopes at 2, negative 1, and 2, positive 1. So how would we find the slopes? What would we need to do first? This was on your quiz. Not the slope equation. We're going to find the derivative and then plug in our x and our y values here because we're going to find the derivative using implicit differentiation. So we'll have y's and x's in our answer. So let's find the derivative first. So let's find the derivative of each term all by themselves. We have y squared. What's the derivative of y squared? 2y, but what do we have to remember to include anytime we take the derivative of y? dy over dx minus, what's the derivative of x? 1, perfect. Plus, what's the derivative of 1? 0. And the derivative of 0? 0. So we get 2y times dy dx minus 1 equals 0. Let's get the dy dx all by itself so we know that our derivative is equal to whatever we have. So here, I'm going to add 1 to move it to the other side. So 2y dy dx equals 1. Then what? Divide by 2y. So dy over dx is equal to 1 over 2y. So this is kind of like 2 questions in one. It wants us to find the slopes at 2, negative 1, and then 2, positive 1. So that we're doing 2 different things. So for our slope at 2, negative 1, we're going to plug in 2 for our x and negative 1 for our y. We don't have an x to plug in anything, so we're just going to plug in negative 1 into the y. So here we would have 1 over 2 times negative 1. Which would be 1 over negative 2. So our slope would be negative 1/2. Yeah, I mean, dy over dx is just telling you the derivative equals this. To find our slope, we plug in the number into the derivative. Your slope is just going to be a number. So when it's asking for the slope, it's just a value. Now let's do the same thing, but with our second point here. So now we're going to find the slope at 2, 1. So I'm going to plug in the 2 for x and the 1 for y. So 1 over 2 times 1 would be positive 1/2. So this would be our slope at 2, 1. So this was asking for 2 separate questions because it gives you 2 separate points. So we just have 2 separate slopes at each point. So I'll call it example 8. So we have 3x squared minus y squared equals 16. Let's find the second derivative. So the second derivative written like this instead of like our y prime prime would be d2y over dx squared. So we're finding our second derivative. Well, let's start by finding our first derivative. We're going to use implicit differentiation here, so we're just going to find the derivative of each term. So our derivative of 3x squared would be what? 6x, perfect. Minus, what's the derivative of y squared? Awesome, 2y dy over dx is equal to, what's the derivative of 16? 0. Now, before we go ahead and find the second derivative, it helps to get the dy dx all by itself and then just take the derivative again of that. So let's isolate our dy dx. So I'm going to subtract 6x to move it to the other side. So negative 2y dy dx is equal to negative 6x. Then what would we do? Divide both sides by negative 2y, perfect. So dy dx is equal to, we can do a little bit of simplifying, we get 3x over y. So now let's find the derivative of this. How would we find the derivative? Awesome. We're going to use our quotient rule. So our quotient rule is low d high minus high d low over low squared. So our second derivative would be low, which is y, times the derivative of our numerator. What's the derivative of 3x? 3. Minus high, so that's 3x, times the derivative of our denominator. What's the derivative of y? 1, but what do we have to make sure we include? Dy dx. Over low squared, so y squared. Now we can't leave dy dx in our answer, but what do we know that dy dx equals? What does dy dx equal? It's on the board. 3x over y. So I'm going to take that 3x over y and substitute it into the dy dx. So you can't leave dy dx in your answer. We got to substitute what dy dx equals and plug that in. So that's why we found what our first derivative was. We isolated our dy dx. Now we just need to plug that in. So here we get 3y minus 3x times 3x over y squared. Can't leave our answer looking like this, so we got to do some more simplifying. 3y minus 9x squared over y squared. You still can't leave a fraction in a fraction, so what should we do next to do some simplifying? Let's combine our terms on top together, make it one fraction on top, and then when we have a fraction and a fraction, we can keep, change, flip. What do I need if I'm combining my terms on top? A common denominator. So I'm going to multiply my first 3y by y over y. Just give it a denominator of y. So now I made it 3y squared over y. So 3y squared minus 9x squared over y squared. Now that we have a fraction, we can keep, change, flip. Keep the top, change to multiplication, and flip the bottom. Be careful when you flip the bottom. Y squared is like a whole number on the bottom, so it'd be over 1. When we flip it, it'd be 1 over y squared. So when we multiply these together, multiply the numerators together, we get 3y squared minus 9x squared over, what would our denominator be? Y to the third power. Perfect. So this would be our second derivative. Good with that one? Okay. Example 9. So given 4x to the fourth power plus 8x squared y squared minus 25x squared y plus 4y to the fourth power equals 0. We want to find the equation of a tangent line at 2, 1. What should we do first? Find the derivative. Perfect. So let's find the derivative. What's the derivative of 4x to the fourth power? 16x to the third power. Then we have 8x squared times y squared. How would we find the derivative of this? Product rule. Since we're multiplying the x's and the y's, got to do the product rule. So I'm going to call my first term 8x squared, and then my second term would be y squared. So the first times the derivative of the second plus the second times the derivative of the first. So our first is 8x squared times the derivative of the second. What's the derivative of y squared? 2y. What are we missing? dy dx. Anytime we take the derivative of y, we need dy dx. So the first times the derivative of the second plus the second, which is y squared, times the derivative of the first. What's the derivative of 8x squared? (16x). Perfect. Now for negative 25x squared y, how would we find the derivative? Again, we're going to use product rule. So be careful because of the minus out front. You can either leave the minus there and just call your first term 25x squared and your second term is going to be y, and do the same thing, the first times the derivative of the second plus second times the derivative of the first, and then distribute the negative at the end. That's what I'm going to do. Or you can include it in the 25x squared to make it negative 25x squared as your first term. It doesn't matter which way you do it, just be careful with the minus. So I'm just going to leave the minus out front. I'll put this in brackets so I make sure I know that I need to distribute the negative at the end. So the first would be 25x squared times the derivative of the second. What's the derivative of y? Awesome. Derivative of y would be 1 dy dx plus the second, which is y, times the derivative of the first. What's the derivative of 25x squared? 50x. Perfect. So if we want to, we really only have two terms in there. I can get rid of my brackets and just distribute the negative to both terms. Bless you. So I just distributed my negative to both of those terms. And then plus, what's the derivative of 4y to the 4th power? 16y to the 3rd dy dx. Perfect. Equals 0. Let's simplify a little bit. So 16x cubed. Here I have 8 times 2 would be 16x squared y times dy dx. Plus, here we have 16x times y squared minus 25x squared dy dx minus 50xy plus 16y cubed dy dx. So from here, you could isolate your dy dx, move everything to the other side. So I think there's a question like this on the homework where it asks to find the derivative and then find the slope. So when you find the derivative, you'd want to isolate your dy dx, move everything else to the other side. But here it's just asking us for the equation of the tangent line. So we want to find our slope. So I don't really need to isolate my dy dx yet. I can make it a little bit easier for us. What would we do next to find the slope? Plug in. We're going to plug in 2 into our x's and 1 into the y. So here we have 16 times 2 cubed plus 16 times 2 squared times 1 dy dx plus 16 times 2 times 1 squared minus 25 times 2 squared dy dx minus 50 times 2 times 1 plus 16 times 1 cubed dy dx. So from here we just have to do the math. 2 cubed would be 8, and 8 times 16 is 128. Plus 2 squared is 4 times 16 would be 64 dy dx. Plus 16 times 2 would be 32. 2 squared is 4, and 4 times 25 would be 100, so minus 100 dy dx. Minus 100. Plus 1 cubed is 1, times 16 would be 16 dy dx. Kylie. I think that you guys could do 16 times 8 without a calculator. That's really the biggest number here. So, no. This I think you could do without a calculator. I mean, you have big numbers, but you're really just adding and subtracting. They're not that big. So let's combine our like terms next. 128 times 30, or plus 32 would be 160. Minus 100 would be negative 60. No, would be positive 60. And then we can combine our like terms with the dy dx. So 64 dy dx minus 100 dy dx plus 16 dy dx. Negative 20, awesome. Dy dx equals 0. Our goal is to get dy dx all by itself, so let's move everything to the left. I'm going to subtract 60. Negative 20 dy dx is equal to negative 60. Divide by negative 20. So dy dx is equal to 3. Nice and easy. What's this question asking us for? The equation of a tangent line. So we have to plug that into our equation of a line formula. So y minus y1 would be y minus 1 is equal to m times x minus x1, so x minus 2. And then we can put it in slope-intercept form. We get 3x minus 6, add 1, y equals 3x minus 5. So that would be our answer.